All right, welcome to this week's Journal Club. Today, Vishaal will be our host. I am Mike. I am from Monash University, currently a PhD student in the Tsuchiya lab. Lipeng?
Hi, I'm also a first year PhD student in the same lab. Um,
Yep. Hello, everyone. I'm also from the same lab and also a first year PhD student. And Vishal, yeah.
Yeah, I'm also from the same lab and I've hopefully just finished my master's. So, yeah, that's about it. So, should I just go, Mike?
Oh, yes, yes.
Okay, yeah. So today we'll be talking about a paper published in July of this year. It's titled A Neurofunctional Signature of Affective Arousal, which generalizes across valence domains and distinguishes subjective experiences from autonomic reactivity. It's a pretty lengthy title. So, and it's a pretty lengthy paper as well. So I'll try to summarize it as best as I can. Of course, we read the paper within 2 hours, so we couldn't quite finish the paper. But yes, I'll summarize it to the best of my ability. So, to give a bit of background to this paper, the study is centered around the nature of affective experiences. So, these are essentially feelings or your emotional experiences. So, up to this point, research conceptualizes affective experiences along two dimensions. The first one being valence, right? That's your negative or positive emotions. And the second dimension is arousal or intensity. So there have been studies mapping the behavioral and neural, I guess, dynamics of valence and arousal, but there are some unexplored aspects. With the first being we don't really have a model for subjective affective arousal that is generalizable across valence states and stimuli modalities. The second unexplored aspect is past studies have focused on autonomic and wakeful aspects of arousal per se, instead of the subjective experience of the affective arousal itself, if that makes sense. So it's important to note this because there are, in fact, distinct neural mechanisms underlying autonomic reactivity versus the subjective experience of arousal, respectively. Right, so to address this, the study essentially sought to develop a predictive brain signature of subjective affective arousal that is generalizable and sensitive to specific emotions. So this is termed BAAS, short for brain affective arousal signature. So the signature is essentially a whole brain multivariate pattern developed from naturalistic MRI data, along with some predictive modeling. And the predictive model itself, we won't go into too much detail, but I'm happy to be happy to discuss it later, right? So the methods is, of course, there's a very detailed account of the methodology, which for this summary, I won't quite delve into too much, but essentially I'm going to highlight the core components of the methodology. So to develop the BAAS, right, the brain signature, there are a few core components, namely, first, it starts with the discovery data set where they did the main analysis and developed the signature. Second is the validation data set where they tested the signatures that they identified in the first stage, the discovery data set. The third component is a exploration of the generalizability of the signature, where they tested the signature can generalize across different conditions, specifically different stimuli modalities. And the fourth component is a specificity analysis to assess if the signature is capturing valence, right, rather than just arousal itself. And the fifth component is regional localization. So they try to identify the brain regions, the specific brain regions associated with the subjective affective arousal processes. Um, so what they'd found was that the signature was in fact generalizable across different valence and modalities. In terms of localization, affective arousal depends on engagement of distributed activity across the entire brain rather than just activity in isolated networks and regions. There was one other point that they spoke about, I think related to the distinction between valence and autonomic reactivity, but I didn't get to that. I didn't get there yet. I didn't have time to finish reading it, so I will, I guess, stop the summary here and hand it over to you guys for the discussion.
Sorry, about the last point regarding the autonomic arousal.
Mhm.
Was they trying to separate the emotional arousal from the autonomic arousal? That's the purpose, right?
Yes,
Okay.
to my understanding and memory, yes, that is exact. That's essentially it. I just briefed over it. I couldn't really read it like in detail. I mean, I had to brief over the whole paper, but um, yeah,
Yeah.
I didn't quite get to that part.
On this point, I think yes, and they try to give an example or some study are aiming to test it. For example, study 23, they try to use the model to predict wakefulness and from sleep and awake, and then it failed. So it means that this model can now predict like pure arousal of physical that not related to emotion. And also they use so-called GSR, which is the skin response as a ground truth of nervous system activation. And they found that the BAAS is not significantly or correlated with this skin reaction. So I think on top of that, on this point, they are trying to say, okay, our model distinguish um, emotion arousal from autonomic arousal.
Mm. Yeah.
I'm actually kind of interested in a similar point. If we look at the graph 5B specifically, this is basically a false alarm versus hit curve, right? If I'm understanding it correctly.
Sorry, which one?
The figure 5B.
5B. Mm,
Maybe I will share screen to make things easier. Give me a second. Yes. So if this is indeed the case, if I'm understanding this correctly, then it is essentially saying the BAS when it's predicting autonomic arousal, which in this case is measured by the skin conductivity. It's essentially making a random guess. So it has absolutely or very close to no power at all in prediction of the autonomic arousal, but it's good at predicting the actual self-rated anxious arousal level, which would suggest it's quite good, quite specific rather, in targeting emotional arousal.
mm.
But I actually have a also related question as well, because if we look at the DEVE study 4 in what is it? Is it 2D? 2D. Um, so this is showing a similar graph, a very similar graph. But it's still BAS trying to make predictions. But it seems for thermal pain and mechanical pain, the BAS is actually, you know, reasonable in making that prediction. I've found it a little bit strange, but I guess the thermal pain measurement is done through rating rather than the skin conductivity. And the rating probably contains both the pain element and the emotional anxiety element, which leading to this kind of reasonably good predictions. But yeah.
Yeah, that's an interesting question. And I also wondering how they define experience or emotion experience here.
I mean, they ask you to rate it. Oh, in the ontological sense, rather.
Yeah.
Okay.
Here they say experience arousal, emotion experience, subjective experience of arousal. And yeah, so I feel confused about this definition, and also the figure you pointed out, the thermal pain and the subjective experience of arousal. That's hard to connect them together, because to my understanding, subjective experience is not similar to what they define.
I'm not, maybe someone else will be able to add more, but I thought it's somewhat similar in the sense that they're asking you to do a self-report. Um, so if I think about like Aniko's more recent task, where she's investigating using a somewhat similar methodology. Of course, there's no fMRI element, but watching video and then you provide a self-report. It should choose.
Self-report by Likert scale, right?
Yes, that's correct. Yes.
Mm.
Uh, yeah, I guess it depends on exact like instruction and questions, I guess.
I mean,
Mm.
they did make an effort to distinguish arousal slash intensity versus subjective experience of affective arousal, right?
Mm.
But I'm not sure if I missed this from just reading pretty quickly, but did they give a formal definition of subjective affective experiences, affective arousal?
I think experience-wise, it's more of just dividing it up into the valence and arousal axes, right?
Right. That's what I
Yeah.
thought as well. Yeah.
But for arousal per se, I have no idea. Yeah, I
Mm,
was because I'm not very familiar with emotion as well. So when they say affective arousal versus autonomic arousal, I can sort of sense the difference, but yeah, I like some more explanation. Yeah.
right. Mm. I'm not
Actually, I have a question. Oh, okay.
Oh, no, you go, you go. I'm just random comments.
Oh, okay. So my question is, in this study, in page 4, top right, there's a paragraph. They say, if they retrain the decoder, maybe let me share my screen. Can you see?
Mhm.
So they say, if they retrain the decoder and excluding the entire occipital lobe,
Mm.
then they observe similar performance, including this uh, this result. So if we take the premise that occipital is related, or the source of conscious experience, and then they exclude entire occipital lobe, and then they retrain the data, and then they found, oh, the performance is the same. That's where I am confused whether they are actually testing the actually subjective experience.
Uh,
But if we say, oh, no, posterior hot zone maybe not directly related to conscious experience. Okay, that's fine. But if we take that premise, then excluding this occipital lobe means that they are not testing something related to experience.
I was under the impression that the hot zone include more than the occipital lobe.
Yeah, so the posterior hot zone has essentially some is parietal regions, some temporal regions, and then occipital regions. And the exclusion of the occipital lobe, right, quote unquote, from the analysis is mainly the underlying intention, to my understanding, is to exclude the visual areas,
Yes, yes.
right? Visual processing. So I wouldn't necessarily restrict conscious experiences to the occipital lobe when, I mean, technically they are including the temporoparietal regions as well. So,
Okay, that makes sense. Okay.
But they do note similar performance, right? Including versus excluding the occipital region.
I haven't checked the supplementary material, so but whether to what extent they are similar, but probably there's some different.
Let me just check that real quick.
On a related note, I think it does lend their argument credence that it's not limited to the visual area. Because again, I think in figure 2D as well, study 18, where they asked participants to imagine positively emotional experience and negatively emotional experience, the BAS, their signature, can still differentiate the two.
Oh, right. The imagination. Yes. Okay, that's clear. Thank you.
Yeah.
Maybe they can even do it in dreams. Who's to say?
Sorry?
You can try BAS analysis on dreams as well, right?
Yeah, that's actually a good idea.
During fMRI?
Yeah.
So there are, I think, a few fMRI studies for. Sorry, did I cut off someone?
No, please go on. No,
Okay, so there are some fMRI studies on sleep, I think, but I've not really read them all too much because I've been reading so much of EEG stuff. Uh, I think this might be a pretty easy answer if I just Google it, but yeah, I was just gonna ask the question, how do you get someone to sleep in a very, very loud fMRI machine? But you know what, I'll just
I mean, I'm sure they have done it
just search it up
before.
real quick. Yeah.
Yeah.
Yeah. I had some trouble understanding what the signature is specifically, but because it mentions just like a whole brain, like statistical pattern, essentially, right? Multivariate pattern. So it's essentially, the signature is essentially a value of just whole brain activity. Am I right in understanding that?
I thought it was more. I see it as more of a mask or like a weight for each of the particular voxel or region or however you want to quantify it. So that there are areas that would be contributing more to this particular arousal level. And then there are those that are sort of anti-correlated to that. And then you just mask it and then feed the fMRI data through it somehow, and then you'll get a sort of output or prediction, something like that.
Right.
That's how I see it, but I'm not sure if, yeah, I may be wrong.
Okay.
This may be a bit technical, but I have a question about the argument that this is a sort of global process, like global brain process, rather than a specific localization. And what the author has done is to do something called a parcellation analysis in figure, what is it? 3B. I can also share my screen. Where is it? Let's see. Yeah, this figure here. So they have looked at, well, each of the areas. They look at it like yeah, what sort of, which of the sort of locations are corresponding to arousal levels, I assume, for part A. And then part B here, they've done something called parcellation based arousal prediction or whatever. That I have no idea what they are doing, but it seems to be saying that it is supporting a global, yeah, the global perspective as opposed to the local perspective. But yeah. Does anyone have any experience of this before? No.
No.
Oh,
I don't think anyone does fMRI now.
but
Oh wait, no,
I think
Aniko does, but
I think I did something about MVPA, multi-pattern, multivariate pattern analysis. It means that when you do the fMRI, then your brain is scanned as a 10,000 or 100,000 voxel. And then to analyze this kind of large amount of voxel is very computative expensive. So you can combine or um, segment this voxel to each block. That's parcellation. And it means that the brain is divided into discrete and some non-overlapped region. And then this slice or parcellation can based on brain connected atlas.
Oh, I see.
Mm.
Uh, okay.
Yeah.
That makes sense. Hmm. So what they're saying here is that there are a whole bunch of, assuming that they're doing this, as you say, over brain regions, where they're collecting voxels based on brain regions.
Yeah.
Atlas, and they're saying that there are a whole bunch of different regions that are responsible, as opposed to, I assume over here, like individual voxels or just small local groups of voxels that are related.
Yeah, I
Right.
think your interpretation is correct. Yes.
I see. Oh, okay.
But it's difficult to say, right? I mean, it reminds me of no report paradigm,
Mhm.
where the response leads to over-exaggerated activities in the frontal lobe.
Oh.
Sorry, I don't understand. How is it similar to a no report paradigm?
Well, it's the it's the report paradigm in this case.
Of
But
yeah. Yeah.
the idea of no report paradigm is that when a participant is asked to respond, all extra brain areas are involved in some cases, depending on how they are making the comparisons. Um, yeah, I'm not familiar with parcellation-based analysis enough to say whether it is indeed the case, but yeah, I would be curious about whether there will be a way to conduct similar measurement, but in a passive way. Perhaps we can track affective experience in other ways, depending on if there are good correlates out there.
You mean there are some area that or some activation directly related to the report of this behavior rather than experience.
Yes, yes. Now, in depending on once again, depending on the way they compare the groups to get this activity map, it's possible that the two report condition are equivalent and they cancel each other out, and then there's no problem. But sometimes it's not always equivalent, even though they behaviorally seems very similar.
Hmm. Is there any way to do that?
Hmm. Is there, from your knowledge about these emotions, are there ways to for us to measure emotional experience without the need to resort to self-report?
Hmm. I think some method related to face muscle movement, but it is facial expression rather than experience. So cancel out. And another thing, more objective measurement, like skin conduction also
Uh,
cancel out.
no, 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 not objective measurements. We are not, I
No
mean,
report, no
yeah,
report paradigm.
the point is whether they correlate well with the actual self-report.
I thought that's the purpose of this paper, is it not?
Mm.
To find out the signature that could potentially be correlated to a report.
Not,
But then,
oh,
mhm.
uh, well, I guess, yeah, for this paper, they are thinking, let me think through that again.
But I see what you mean. I see what you mean. Like it is sort of intermixed. It's difficult though.
This paper say
Yeah.
that their results support a constructive theory of emotion, which means that people have a core effect at first place, and then they need to report. They need to conceptualize, verbalize the experience to some discrete emotion. And what they are measuring here is about the one of the aspect of corn experience, which is arousal. Corn experience is about arousal and valence, and then we need to verbalize it to happy, joy, fear. So in at here, I don't think there is a way to uh,
Um, about these core effect,
yeah, yeah.
if you don't verbalize, you don't report them,
Mm.
do they still exist, or is it just the more upper level emotions that don't exist if you don't verbalize them?
Do you mean the existence of what? Of corn effect? Or corn
Uh,
effect?
yes, arousal, valence. Like
Yeah,
if
yeah,
you
yeah.
don't report them, they still exist.
First, we have corn effect, and
Ah,
then
ah,
we verbalize it.
yeah, yeah.
Yeah, that is, I think this study is based on this kind of framework. Oh,
Okay, I mean that would be perfect for a no report paradigm because the theory would also suggest that you should be able to, in some way, measure core effect even
yeah,
without the self-report.
yeah, yeah.
Yeah. Mm.
And what I found interesting is this paper, if we can get the data of video material, and I try to look for the data availability. I think they didn't provide what video the participants are looking at. So I'm thinking about because they provide the data of fMRI when looking at video. It is a very nice data set for us. If we can have a video, then we can do the video quality structure and then connect it to our neural substrate that's supporting this experience. That would be really cool, but unfortunately, they didn't provide a video material.
But we can reach out, we can send them an email and ask them for it,
Yeah,
and
yeah,
they
yeah.
probably will give it to us.
That would be fantastic. And one thing I'm concerned is if I ask, hey now, or uh, do do you want to um, do like a quality structure and informational structure on their data set? And and fMRI is really slow actually. Probably my perspective from my perspective, I don't think it can review the conscious experience change. Yeah, but who knows, right?
Yeah. The video is like 25 seconds to 1 minute, right? That's
Yes, yes,
the
very long.
yeah.
And
Mm.
about uh and also Mike, you mentioned about unequal study, emotion numbing. I'm also curious about emotion numbing and the arousal, the relationship between them. And what's your opinion about this paper in terms of the
Uh, I'm not sure. I don't think she has, well, we have a very strong interest in arousal
oh,
as a psychological construct. We did do an investigation into what is it? The negative capability related to, the emotional numbing, but that's not, I guess, the focus of this paper.
oh, okay. Yeah.
Okay.
Pretty much I already asked all my question and all my comments.
I would like to say that this paper is kind of crazy though, because it has like 28 experiments.
Yeah, it does. If I'm not wrong, it also used the typical cross-validation method that you see that Lipeng and I are also using. It's not exactly the same, but something to that effect, right? Because they're training, I mean, you can draw parallels and say they're training on one data set and then they're testing another data set. Here they develop the signature on one data set and then they completely just validate it on another.
Mm.
But they didn't use like a register report format, did they? Did they say? I don't think they've mentioned that at all. So they just did it. Yeah, they just did it. Okay.
I guess if you want to register like 28 experiments, it's going to be a bit difficult.
Yeah.
And also
Mm,
cross-validation is about the evaluation of generalizability of the
Mm,
model.
mm, mm, mm,
So
mm,
probably no need for registry report, I think.
okay,
mm.
that's true. So what's the verdict, folks? Do we think we found the neural correlates of arousal, a very effective arousal specifically?
I, I don't know. I think it's promising,
At
but
beginning, yes,
sorry. No, no, Leap.
yeah, at the beginning, I highly doubt this arousal.
Mm,
So first, this model is a black box. I don't know what they are
mm,
predicting, okay? Why they can have such a good performance.
that is true. True, true, true,
And
true.
second, they just exclude some possibility that using GSR, which is skin conductant, skin reaction, and also wake and sleep, to say as an example, saying that oh, our model is not predicting the what is that? The
Autonomic?
autonomic reactivity. So they rule out this autonomic reactivity by several example, but can it take us to the emotion arousal? I highly doubt it.
Oh, what would be your criteria of evidence for something like this?
For the emotion arousal, right?
Yes, yes.
Hmm. So to me, I don't have really nice criteria to say, oh, arousal, because I'm not in this framework. I don't think emotion can be explained by two dimension.
Ah,
Oh.
Oh yeah, similarity. Oh, we are doing our own thing, aren't we? Yes.
But
Mm,
their study is pretty nice and within their framework, I will say. Mm.
Hmm. But also to very quickly correct what Mike you mentioned earlier.
mm.
I think they're very specifically highlighting that they are not measuring arousal per se, but affective, subjective affective experience of arousal, right?
We are not so sure about the experience part, but
Oh
it's
yes, yes, yes.
not the vigilant arousal. It's not the autonomic arousal. So
So
it's
so participants' subjective rating of their affective arousal essentially is what you're saying. Yeah.
yes.
Like I'm awake and I feel this way, and this is how I perceived it. That's my understanding of what they're measuring right now. So
Mm.
yeah. Okay.
Is there any more questions for today? No? If there's no more, then this will be the end of our today's journal club. We'll see you next week. Bye bye.